Suppose that f of 1 plus x is equal to f of x for all real x. If f is a polynomial and f5 equals 11, then f of 15 over 2 is one of these options, possibly not uniquely determined. I'm not really sure how to approach this exactly. I'm also not really sure how the fact that f is a polynomial will sort of come into what will matter here. You know what, maybe, I think the answer might just be 11. It's certainly true. Okay, so if f is a constant, that is, I would say, technically, that's a polynomial. And if f is the constant 11, then it satisfies the relation on the left. And now that I think about it, that relation we're given, Can this hold for all values of x for any polynomial which is not constant? Okay, so now that I've thought about it a little bit, my instinct is telling me that the answer is that f of 15 over 2 is equal to 11 because f has to be a constant. But I want to convince myself that if f is a polynomial and satisfies this, then it must be a constant. Okay, well, for one thing, you know what? If I write this like okay, yeah, so I'm right, and let's see why this works. So we're given that f of 5 is equal to 11. Let's just call that, I'm not drawing this to scale, obviously. That's 5, this is 11. And we have that the polynomial has to pass through every single one of these points because of the relation that I have written above. And if f is a polynomial, then, if f is an nth degree polynomial, then it can have at most n values of x where it's equal to this constant. At most. But that's unless it's the constant polynomial. Unless it's a constant polynomial. But we have that it's equal to 11 at an infinite number of points. And so it must be the constant polynomial. Right, so I'm getting here that f of 15 over 2 has to be equal to 11 because this polynomial has to be a constant. Yeah, this one was pretty cool. When I first looked at it, first read it, I really wasn't sure what approach I would take. Thinking about it, rewriting this as this, for some reason, sparked something that it sparked a thought where I realized that f had to be the constant polynomial. It was nice to recognize that the constant polynomial works given the information we have, and the set of answers that we can select from. But, you know, it's certainly possible that the non-uniquely determined answer was correct rather than the specific answer 11. Anyway, if I have more to say about this one, I'll put it down in the description. Thanks for watching.